Hello, Math 7 students. We are about to begin our 12th video. The video is called Equations of Graphs of Proportional Relationships Involving Fractions. So we already know that the relationship is proportional. So we're going to be looking at the equations and also graphs. But the big thing on this one is that they're using fractions. So it's on page 30 in my comp book, so I'm going to turn there now. You guys have been doing a really good job about remembering to put your titles. Will you please make sure that you remember to keep putting your titles up at the top? So, equations of graphs of proportional relationships involving fractions. Our goal. Today we are going to use equations and graphs to represent proportional relationships. The question I want you to be thinking about is, what must a relationship have to be proportional? So we're going to start this lesson out by just trying a task, and then we'll talk about how the equation and the graph and the table all tie together to help us find information. So, for example, the first little word problem or story that we have to work through is called 10-kilometer race. Sam's mom is running a 10-kilometer race. She runs 5 kilometers in 1.5 hours. What is the constant? So our job together is to figure out what this would look like. And the way that I would like you to do this is I would like you to make a table where you have hours per kilometers. I would like you to build a graph where you have the y-axis is kilometers because it's the y, and x-axis is hours because it is the x. Okay, and then we're going to come up with an equation. So the first thing that I would like you to do is I would like you to put the information that we know. So if we go back to the story, it says Sam's mom is running a 10-kilometer race. She runs 5 kilometers in 1.5 hours. The question that we want to find is, what is the constant? So we know that for every 5 kilometers, that goes under the kilometer side, for every 5 kilometers, it takes her 1.5 hours. Okay? And so our job is to build this table a little bit more. So if I do 10 kilometers, right, because it's a 10-kilometer race, how did I get from 5 to 10? Everybody should be thinking, okay, well, I multiplied it by 2. Well, if you have 2 1.5 pieces, think of it like a cookie. You have 1 1/2 cookie, and you have another 1 1/2 cookie. How many cookies do you have in total? Well, the answer is 3, because 1.5 times 2 is 3, okay? But that's not exactly what we were supposed to figure out. We're supposed to figure out the constant. So who remembers how we find the constant on a ratio table? I'll give you a big, gigantic hint. Y divided by X. That's how you always find the constant or the unit rate. So we're going to take 5 divided by 1.5. We're also going to take 10 divided by 3. Okay, and now I'm going to do that on a separate sheet of paper because I'm running out of room. So 5 divided by 1.5 looks like this, written as a division problem. And the first thing that my brain is telling me to do, okay, I need to change that into a fraction greater than 1. And so I'm going to put equals, and I'm going to change this into a fraction greater than 1. 2 times 1 is 2, plus 1 is 3. So this is really 3/2, and this is 5. So now I have to ask myself, how do I get from 3/2 down to 1? Because that's what the unit rate is. We're trying to find per 1. So how did I get from 3/2 to 1? Well, if you remember that rule, the way that you can find anything that is to 1 is by multiplying it by the reciprocal. And let's do it so you can see. So the reciprocal of 3/2 is 2/3. What is 3 times 2? That's right, 6. What is 2 times 3? That's right, 6. Boys and girls, what is 6 divided by 6? The answer is 1. So see, you found it. Now what you do to one side, I multiplied by 2/3. I have to do to the other, so I have to multiply the 5 by 2/3. And so I have 5 over 1 times 2 over 3 equals, multiply straight across, 5 times 2 is 10. And 1 times 3 is 3. And so for every 1, I have 10/3. 1/3, which is the same thing as 3 1/3 for every 1. Okay? Did I find the constant? The answer is yes. So the constant on this one is that I take 1.5 times 3 1/3, and I should get 5. Let's double check it and make sure that I did that. Excuse me. So I'm going to take 3 1/3 times 1.5, and let's see what the answer is. Okay, so that's 3 times 3 is 9, plus 1 is 10, so this is really 10/3, times 2 times 1 is 2, plus 1 is 3, halves. Now I'm going to multiply straight across. 10 times 3 is 30, and 3 times 2 is 6, and 30 divided by 6 is 5. Ta-da! So the constant between this one and this one was 3 1/3. Does everybody see that? So what I did is I took 1.5 and I multiplied it by 3 1/3. That's what I did right here. Okay? So now let's check 3 to 10. Okay? Same thing. Remember, it's y divided by x. So I'm taking 10 divided by 3, and I want to find out how I get to 1. So I say to myself, how did I get from 3 to 1? I divided by 3. What you do to one side, you have to do to the other. 3 divided by 3 is 1. 10 divided by 3 is 10/3. Oh, look! They match. 10/3 and 10/3. So we know that it is 3 1/3 for every 1. So, again, what is the constant on this one? You are correct. It is that I multiplied 3 by 3 1/3. So let's test it on this paper over here and make sure. So we have 3 over 1 times 3 1/3, which is the same thing as 3 over 1 times 3 times 3 is 9, plus 1 is 10, so I get 10/3. 3 times 10 is 30. 1 times 3 is 3. 30 divided by 3 is 10. And look right there, the answer was 10. So we did it right. Okay? So the constant for this table, remember m is another way to show constant. The constant for this table is 3 1/3. Okay? All right, so now what we have to do is we have to graph it. So we're taking our two ordered pairs right here, 1.5 and 5, and 3 and 10, and we're going to graph it. Also, because remember, it cannot be a proportional relationship unless we have our origin. So there we're going to put 0 and 0 on there. So we need to go and put our numerical values on the bottom. And since we're going 1.5 and 3, then I would say, okay, let's do, here's a half, here's 1, here's a half, here's 2, here's a half, here's 3, here's a half, here's 4, here's a half, and here's 5. Does everybody see how we did that with our numbering? Okay, and that's the x's. And now we need to do the y's, and it says 5 and 10. So I'm going to say, here's 5, here's 10, here's 15, here's 20, here's 25. So what am I counting by down here? If you said I'm counting by halves, then you're correct. What am I counting by on here? If you said by 5, then you're correct. And don't forget to put your 0 on the origin. Okay? All right, so now our first ordered pair says 1.5 to the right, 5 up. So I'm going to go 1.5 to the right, and I'm going to go up to 5 and put my first point. Okay, my second point says to the right 3 and up to 10. So I'm going to go to the right 3 and then up to 10. And then my last ordered pair is 0, 0. And so now if I connect all of my dots, which I can do with my ID, then I will notice that my graph has made a proportional relationship because it goes through the origin, it has a straight line, and it also has a constant. Okay? So now we have to go to writing the equation. What is the equation that we use every time we are working with a proportional relationship? if you said y equals m times x, then you are correct. But we know what the m is. We wrote the m right here. So for this specific 10-kilometer race, our equation is y equals m. What is m? 3 1/3 times any x value that we put in there. Okay, and we just proved that by looking at our ratio table. All right, so that's how you do it. Let's go back to our question real quick. What must a relationship have to be proportional? I hope you can answer this question right now. We've been saying that a lot. All right, we do have another page, so let's take a look at the other page. We're going to try another one, and this one is called Cooking with Mushrooms, okay? And I don't know if you like mushrooms. I love mushrooms. I put mushrooms in our gravy last night at home, and my son Jackson went, bleh, I'm not eating it. So apparently kids don't like mushrooms, but adults do. All right, cooking with mushrooms. Mushrooms cost $4 for a half a pound. $4 for a half a pound. How much does it cost to buy 20 pounds? Okay, so we're going to make our table. The ratio table is pounds per money. So you put your pounds over here and what they cost over here. Okay, then you're going to make your graph, and because pounds is in the x side of the table, it goes on the x axis. So I wrote pounds down here. Y is the money, so on the y axis I put my money, and I'm going to graph it right there. And then I'm going to remember that I have to find my constant. Okay, don't forget to find your constant. I'm going to put a little reminder on there that your step in here for finding constant. So we're going to put constant. The way you find your constant is you take y and you divide it by x. Don't forget, you need to find your constant, because then once you find your constant, you can find your m, remember, because your constant is the m, and then you can write your equation. Remember, the equation is always the same. It's y equals m times x, okay? And since we have the m, we're finding the m up here. Make sure you find your constant. All right, I'm not going to do it for you. You have to try it, and we will check it in class tomorrow. Okay, so one more time. Today we are going to use equations and graphs to represent proportional relationships. We did that. We made a graph. We wrote an equation. We found the constant so we could write the equation. What must the relationship have to be proportional? Everybody, on the count of 3. 1, 2, 3. A constant. Very good. It has to have a constant. All right, my darlings. Finish this one up with cooking with mushrooms, and I will see you all tomorrow.